All right. I got a thumbs up from the video guy. That's good. Hi. I think everybody's still in line for tacos. Either that or everybody's already bored about application security. That's all right. We'll talk anyway. Small crowd means we can have a conversation. So we're going to talk about the OWASP Top 10. Now, normally it's an absurdly boring topic, but recent things have made it kind of more interesting. So we're going to have an interesting talk about the OWASP Top 10. How's that? All right, so who am I? My name is Bill Sempf. I am an application vulnerability analyst. It's a lot like a pen tester, except instead of having a goal and doing pretty much anything that's needed to reach the goal security-wise, my scope is much narrower and much deeper. I take one application and find all of the potential security problems in it, and then write down for the developers how to fix it. Now, you've probably seen those reports if you work for anybody in the financial institutions, because PCI requires them. If you don't, you might not have had an event like that, where you take one application and find everything that's wrong. My job is not exploitation. I do not use Metasploit, for instance. My job is finding vulnerabilities in applications and explaining to the coders what they need to do about it. That's my job. The OWASP Top 10 is a list, one of many lists of those kinds of vulnerabilities. We'll talk about that in a little bit. I have been a developer for a long time. I worked to move the Ohio State University library system from Gopher to web in 1992 when the RFC was approved for HTTP. This was back when to get things rolling, we had to download and compile the web server from CERN's FTP site. So I've been doing this for a very long time. So I worked for about 20 years as the term is enterprise architect, but it's stupid. I hate that term. But that's what they call us. The people who figure out what technologies we're going to use to build the products, the customized code that you have to build, to get certain enterprise software to work, right? That was my job for a long time. And I gradually just migrated more and more into the security space until I got everybody fooled enough that they would start hiring me as a security person. It's worked out really well, actually, because all the security people think I'm some uber coder, and all the coders think I'm some uber security guy. And they're both blindingly wrong, but that's okay. It doesn't matter as long as I have them fooled. Personally, I live in Columbus, so it was a wet drive up here. I live on 5 acres on Hell Branch Creek. I brew there. I didn't bring any beer because there's free beer. So I mean free beer, right? Am I right? I also live in a wood heated house, so that's why you'll see lumberjack in my word cloud up there. I am a ninja, not like a ASP.NET ninja, like actually a 5th Q in Banshee-Chukai Ninjutsu. Notwithstanding, I still disappear on occasion. So if I do, I apologize. I'll try to remember not to do that. Is there anything else up there? Oh, and I'm newly a Microsoft MVP, which is really funny because I wrote 16 books about programming for Microsoft and they ignored the hell out of me. But when they found out I switched to security and can hack their shit, suddenly they made me an MVP. I don't know why. But it's nice to get Visual Studio for free now, so that makes me happy. Anything else? Oh, I run the Columbus OWASP chapter. So if any of you are from Columbus and do not already know that we have an OWASP chapter, we are on meetup.com. Cleveland has an OWASP chapter. If you do not go to it, you should. Better send your programmers. That's what OWASP is for. Let's talk a little bit about what OWASP is for. Well, what is OWASP, right? It's the Open Web Application Security Project. What it's designed for is to get together a group of developers and teach them application security. That's the goal. It's a religious experience group where we're going to spread the religion of application security. About 41,000 people on the discussion list and mailing list and various project lists that are involved in application security one way or the other. And OWASP does 3 things. One, they hold chapter meetings. Thus the Columbus chapter, Cleveland chapter I was talking about. And at the chapter meetings, we do what You normally do at a meetup. We have a speaker and stuff like that. Have food, maybe have beer if it's in the evening. The second thing to do is they run conferences. Now, you've probably been to security conferences before, but security conferences are very broad. Over here, somebody will be talking about a new Cisco vulnerability. Over there, somebody will be talking about risk assessment. Over here, somebody will be talking about legal stuff. Over here, somebody will be talking about social engineering. At the OWASP meetings, at OWASP conferences, it's all application security. So everybody's talking about threat modeling or exploiting cross-site scripting in a new way, or the newest bugs in Electron, or all these kinds of things. It's much more narrow in focus and much deeper because of that. So it's like 200 level talks everywhere, because everyone assumes you already know the basics of app security. It's very, very neat. They have regional conferences and they have big national ones. The national one this year for the U.S. is in San Jose, California in September, right? Or October? September. Sometime. And if you have people that are interested, please feel free to reach out to me. There are often ways we can get you in for not as much money as they want you to pay. Though it's a very reasonable conference as conferences go. I think it's like $700, which is not bad. But we can even do better than that if you like to send people. So that's the second thing to do. The third thing that OWASP does is project. And that's probably the most visible thing they do. And there's two kinds of projects. One kind of project is actual products, coding developed products. One of the most famous is Z Attack Proxy, ZAP. And if you do any kind of testing at all, you've probably run into that before. It is a proxy that sits between the web server and the web browser and allows you to modify the requests and responses in such a way to break a web application, find vulnerabilities. That is a project sponsored by Mozilla, written mostly by Simon Bennett, but it is an OWASP project, so it is free, completely open source, and 100% free. It is comparable to Burp Suite, if you've ever played with Burp Suite before. Burp Suite is not open source. It's not an OWASP project. It is very good, and I use it every day. But it is a paid product of Portswinger, and it is it's not open. You can go browse the source code of ZAP, which is very nice. So that's one thing that OWASP does. They support these coding projects, of which there are lots of, not just attack ones, there's defense ones too, like App Sensor that will go through and look at your source code and find dependencies that have known vulnerabilities. So for instance, if you're using an old version of jQuery, I can find that in a vulnerability assessment, right? Because I can look at the code, it's JavaScript. But if you're using a vulnerable version of ImageMagick on the back end, in your, deep in your server farm, I won't know that unless I happen to find the vulnerability in the image upload. But App Sensor will find it because it looks at your source code of your project. So that's the second thing that OWASP, or third thing, the first kind of project that OWASP does. The second kind of projects are documentation projects. I run one of those, the .NET project. We document all the gaps in the Microsoft's .NET documentation with regards to security. So, for instance, there's an article up there about how to implement PBKDF2 for password hashing. Most people don't know that that's actually baked into the .NET framework, and they feel they have to implement it themselves or use a third-party library. You don't. It's in there. It's just named funny. So we wrote an article on how to utilize it. It's kind of cool. The most famous OWASP documentation project is the OWASP Top 10. What the OWASP Top 10 is, it's a survey done every 3 years where they, the OWASP powers that be, request that vulnerability assessment and pen test organizations and static scanning companies anonymize their test data and turn it in, so that they can count how many and what severity all the vulnerabilities they discovered was. So they do this every 3 years. They get this big block of data. They have an Excel template you're supposed to fill out or import into or whatever. And I participated. If any of you out here are my customers, your data sanitized of your company and any information, of course, just what vulnerability it was and how far it went. It went into the OWASP Top 10 for 2017. It went. They go and they count all the findings, and they say, okay, let's rank these by how many of them were discovered, and then balance the actual risk of the vulnerability in with it. And what they do is they make a list of the top 10 pieces the top 10 vulnerability pieces that are most apt to be discovered in a web application. Now, many people attempt to make the OWASP top 10 their entire application security program. That is never what it was designed for. As I normally say, the OWASP top 10 is designed to print out, roll up, and smack your CIO with until they give you the money to fund the application security or train your developers. That's what the OWASP top 10 is. It's a marketing piece. Even OWASP said that. That was what it was designed to be. It's a splashy, easy to read, easy to ingest documentation project about these vulnerabilities that people discover in applications. Instead, what it has become is the de facto guideline for app security. These 10 things. I want to train my developers on the OWASP top 10. Well, no, you want to train them in secure coding. The OWASP top 10 is just out there to gain visibility for application security. But it became more than that. And what happened, even though OWASP has a very, very strict vendor neutrality policy, over the years, vendors discovered that because companies were using the OWASP top 10 as their de facto AppSec policy, that if they could build products that matched what was in the OWASP top 10, they would be able to sell more easily. Then, unfortunately, a couple of companies realized they might be able to actually alter the course of the top 10 to match their products. Very subtly, but the original beta, I'm not going to get into the politics of this, but the original beta version of the 2017 OWASP top 10 had a particular vulnerability in it that exactly matched existing marketing of one of the companies that sponsors the project. And as I'm sure you can imagine, the community went apeshit. And to their credit, the OWASP cleaned house. The people who ran the top 10 project stepped down. They got a completely new group. They reran the survey, and they created a totally new list. Totally new. The OWASP top 10 has not changed very much in a very long time. Because, frankly, we have the same problems in application security we've had for many years. Not much has changed. But some has. And it's exciting to see that the transparency that went into this new version, which is why I'm here talking about what's new in the OWASP top 10 2017, but it's 2018. It took a while for this whole process to take place, right? It's nice to see that the transparency has driven a really quality product. So as you can see from the slide, really a lot of things have not changed. Injection is still the highest risk vulnerability that applications encounter. And it has been, I think, since 2002 when the first OWASP top 10 came out. I'm not positive about that. I should check that. That's actually a good fact. But so many things have not changed. But some things have, and here's what I'm going to do is I'm going to walk through each of them and explain what did change and why, and how it impacts you and how it impacts your developers. And then if we have time at the end, I'll show you a couple of examples of why this matters in actual code. Unless you're all glazed over by then, in which case we'll just go drink beer. So let's talk about injection. Injection has been the top of the top 10 for a long time. For a long time, it was just called SQL injection. But what happened back in 2010 is that they realized that a lot more things were being injected to than SQL servers. But of course, SQL injection is the one we all hear about. Whenever you talk about application security, SQL injection is always the thing that comes up in conversation. Why? Why is it such a big deal? Because I can download your database. If you have a SQL injection vulnerability in the application, you have no way of knowing it unless that application has been tested. But if I find it, I can literally download all your stuff. And that makes it a very, very high risk vulnerability. But it's not just SQL that can be injected. So they changed it to just say injection, and they specify a lot of the details as far as what can and what has potential for injection. But injection has an easy fix. It's just difficult to find time to implement it. What causes injection? the ability to run, if I'm an attacker, I'm running my code on your back-end system, whatever it is, a SQL server, a NoSQL database, LDAP, directory server in general, XML, even an XML parser, an operating system, right? Any of those pieces is if I can fool your application into confusing data and code. That's the trick, right? If I can send code in and you process it with your back-end system as if it's code, then that I have successfully exploited injection. So what's the solution to this? We teach our developers to do effective input validation so that the data and the code are never confused. It got a little tougher when they changed this to say injection instead of SQL injection. Because when it was SQL injection, we could very easily say, parameterize your queries. Let the database do it for you. Well, now it's a little tougher than that, because now we're running into things like operating system injection. And you can't parameterize an operating system message. If you're accepting a file name from a user in a drop-down box, right? And, but of course the drop-down, the select statement doesn't matter. The select in HTML doesn't matter, because I'm attacking with a proxy. So I can put whatever I want in there. And then you're passing that file name to an operating system operation to do something with that file. If you don't validate that that file name is exactly one of the pieces of data that you're expecting before you process it, then I have the opportunity to run my code in your operating system. Does that make sense? That validation takes a lot of time on the developer's part. They have to compare input, any kind of user input, against known good values. And finding that time when trying to get a product out the door is very difficult. But the lack of that input validation is what causes injection. And they make that very clear in the new version of the OWASP Top 10. I failed to make an important point here. The actual OWASP Top 10 is more than just a list. It's actually like a 14-page document. Each one of these vulnerabilities has a full page of you might be vulnerable if and what to do about it. So that's what we're working from here. And your homework when we get to the end of this is to go download the PDF and read it. It doesn't take long, and it'll give you a much better understanding of what we're dealing with here. So that is injection. Injection did not change significantly from 2013 to 2017, but it is still out there. The second of the ones that didn't change very much is broken authentication. And by the way, the porter is very good. It's like chocolate milk. Love it. So authentication is part of the access control suite, right? You have to make the user prove who they are. You have to find out what that user can do. And then you have to maintain state in the application. Authentication, authorization, and session management. Broken authentication, the Zen example is if I see a login screen and I type in a known username and leave the password blank and submit and it goes through and logs me in without a password, that is broken. You would not believe how often I find that in tests. If you put in the wrong password, it'll fail you. But if you put in no password, it's totally cool with that. I don't know why. Anyway, but as it turns out, authentication is a very high risk because there's a lot to the threat surface of authentication. Realistically, an attacker trying to attack an application has one threat surface to work with, that login screen. That's the only thing they can see. Very difficult to go find SQL injection if you can't log into the application, right? So it's not so much that broken authentication is an extraordinarily common problem. It's just an extraordinarily dangerous one. If I can break into the application, bypassing the authentication system, then I can get access to the rest of the application and test for the rest of the vulnerabilities, like injection and whatnot. So a lot of stuff falls into the authentication space. Just moving around or something. For instance, if you fail to do anti-automation, so if I can continue testing passwords without you locking my account, that is broken authentication, for instance. If you allow weak passwords, You know, you don't have a character restriction when they set up their accounts, or you don't require a certain number of alternative characters in your password. That is broken authentication. All of those pieces fall into this category. Didn't really change very much from 2013 to 2017, but I'm glad it's still up there. Now, sensitive data exposure has always been on the OWASP top 10, but it is does have a new feature now. Sensitive data exposure has historically been when, for instance, you produce a mobile app, but you leave your API keys in the source code because it's compiled, right? They can't find it. Well, they can't find it. It's very easy to decompile an application like that. Or if you have a single-page application, like, say, written in Angular or React, and you keep your keys in the front-end JavaScript, well, then I can access your keys. You know, that's not going to work. That was sensitive data exposure. Even if you have, like, developers' names in the comments, so I can go look up their LinkedIn profile, look up their Stack Overflow profile, and see if they've submitted any bugs or asked any questions that might lead to security vulnerabilities in your application. That is sensitive data exposure. But now they've changed it. That's still there. But they're also saying if your application accidentally exposes personal information of your customers, that is sensitive data exposure too. So, if I can, for instance, I tested an app 2 weeks ago, where if I logged in as an area manager, I could, and I'd say, give me a list of my leads. What the app actually did on the back end is download a JSON file of all the leads, and the front end only showed me mine. So at the UI level, I only got to see my leads. But what was actually downloaded to my machine was every lead in the system, and the JavaScript filtered it. That is sensitive data exposure now. So it's definitely something to look for in your applications. So they use the term access control here. I use the term access control slightly differently. I use the term access control to mean the whole suite of getting to an application: authentication, authorization, and session management. To them, access control is authorization. So this is, for instance, if you have, if I can force browse to a part of your application, and it doesn't show up in the navigation, but if I know it's there, I can force browse to it, even if I'm not allowed to have access to it, it still shows it to me. That is what broken authorization or broken access control is to them, to the OWASP people. I do not like this use of the term access control, but we have to stick with it because it's printed on the document. What are you going to do, right? I mean, what are you going to do? So if I can modify the URL and get access to information that I'm not supposed to have access to, if I can modify a identifier for a record. So anybody remember when Weave was sent to prison for Andrew AT&T thing, right? So do you know what happened with that? Yep. He says he changed one digit in the URL and they sent him to jail. That is exactly right. He discovered that the registration system for iPads and iPhones on AT&T's network left the IMEI in the URL, and if you enumerated the IMEI, so it's a number, right? If you enumerated backwards, you could see everybody who'd ever registered and all their information, everything they were using their iPad for, all their account information, all their address, their phone number, everything. And of course, though it's true, what he did was enumerate a URL and go to jail. What he actually did was brag about it and then give the judge a hard time because he's an asshole. But still, sorry, that's true. I know him well. You can't do that. But that is broken access control, right? He should only be able to see his iPad, not everyone's iPad. They should have been checking authorization, and they weren't. So that's broken access control. That has not changed significantly in the new version of the OWASP Top 10. Security misconfiguration is a huge bucket of junk. So my Zen example of security misconfiguration is if you're using S3, Amazon S3, to store files in, and you just leave it open because you can't figure out how the authorization works. Yes, technically that's broken authorization, broken access control, sorry, but it's a security misconfiguration because that's not something you have to code for. That's something you press buttons on Amazon's website or it has a config file. So for instance, if you're a .NET shop and you have turned off custom errors, right? So I get the yellow screen of death if your ASP.NET site blows up. That's security misconfiguration. Anything that involves a config file is a security configuration flaw. I don't particularly love this. I wish they would be specific, but if there were, it'd be the OWASP top 20, because there's a lot of things in security misconfiguration. But it's definitely, it hasn't changed any significance. They've added some stuff in the language related to, they've updated all the frameworks. So one of the items is the security settings in the application servers, application frameworks. For instance, struts, spring, ASP.NET. It used to say like MyFaces, PHP, and old stuff, and they've updated it to newer things, which is nice. But largely, this is a catch-all bucket, right? This is, you got to check your configuration. The one thing they did add, configurations must be human readable for auditing purposes. I like that a lot. That's something that I definitely hit on people when I do white box testing. And if they have fully encrypted their config files, or if they have encoded them in such a way that they are not easily reversible, not by the attacker, but by the people who work there, then that's a bad thing, because configuration should be auditable by the people who run the application. So that's definitely a good addition. Crosssite scripting, of course, has been around. It was bumped far down the list. It used to be A3, it's now A7. You probably all know Crosssite scripting and what it's all about. Basically, Crosssite scripting is injection. It should be in with A1, but it's browser injection, not server injection. So because with server injection, A1, we're affecting the backend system, which affects everybody's account, right? With browser injection, we're affecting one person's account. So if I can create something that runs my JavaScript in your session, your web session, then I will be able to take over your session. But it's just you. It's not everyone. So because of that, they decided to move it on down the list and make it a little bit less high risk because of that piece. But cross-site scripting has become a very interesting piece because we have so many JavaScript-based applications now. Before we were using JavaScript to do some stuff, but pretty much everything was request and response, post and get back to the server. And now we're doing a lot more just front end using these JavaScript frameworks. DOM cross-site scripting. So cross-site scripting that I can use just the front end. It never goes back to the server. So all your filtering does nothing. I can construct a URL that will still cause my JavaScript code to be run in your session, even without a server call. It's hard to do, but if you can do it, it's very powerful. And you probably get a lot of phishing messages based on DOM cross-site scripting attacks in various places. It's been discovered in lots of large-scale applications, including like Amazon. So they fixed it since, but there were 4 findings. Somebody did a write-up on them. It was through their bug bounty. So I mean, even Amazon's a big company, right? So still a very real threat, just one user at a time. And finally, known vulnerable components. This has been on there for a couple of years, a couple lists. This is not unlike security configuration. It's kind of a big bucket. It's basically saying, hey, if you're not keeping your stuff up to date, you're at risk, right? Not just front end, back end too. If you're using an old version of Java, if you're using ASP.NET, 3.5, you're not running your patches. Those kinds of things are going to be a security risk as well. So that's all the stuff that pretty much didn't change year on year. And in fact, a lot of it hasn't changed for many, many years. But because of the big schism that happened, there are actually 3 totally brand new items that reflect the new environment we're all working in. The web and coding for the web has just increased in speed at such a miraculous rate. People get significant things done very quickly, and we're standing on the shoulders of giants, right? We have very, excuse me. very, very powerful libraries that we can use in .NET. We've got all the stuff that's up in NuGet. Node has NPM. We have all these libraries that we can access and do a bunch of the work for us. So we really just get to peg together pieces, as long as we keep them up to date and don't have overflow into relationship hell with all of them. But it makes the speed of development much, much greater. And it leads to these new findings that are showing up in contemporary applications. And I'm glad to see that OWASP finally kind of reached out and made some changes for it. Let's talk about them for a couple minutes. So XML external entities. This is funny because my first speaker note says redo that image because it doesn't make any sense. XXE is difficult to explain easily, but more or less, anytime you're using an external file in an XML document. So if you have an application that is moving an XML document into another application, right? So say you allow a user to upload an XML document in a business setting. This is obviously not something you would do on the public web. Or you somehow have an XML document that's editable by a user because it has been moved to their machine for processing to show in, say, JavaScript or something like that. They make some kind of change to it and then can move it back up to your server. XML documents have the ability to reference outside files using the entity tag. And that's most often used, for instance, to add a DTD, a data transformation document, that describes how the XML should be viewed by a viewer, and also what format each of the pieces would be in. Anytime you reference an external file, you have two possible real problems. One is local and external file inclusion, right? Remote file inclusion, LFI and RFI. There is a chance that I can reference a file on your system. So I'm the attacker, and I have the ability to modify an XML document that's moving to your server. Then your XML parser is going to parse it. There is a chance I can reference a file on your server. When your server displays the edited XML document for me, they're going to reach out and grab a file in your system, say your Etsy password file, for instance, which would be awesome, or your configuration file for your web application, which shouldn't be viewable, and parse it as part of the XML document. So that is an external entity. I have forced your system to go reach out and grab something in your system and display it to me. Even if it isn't shown on the screen, it might be hidden in the source code of the web application, and I can easily go find it with my attack proxy. This is not a particularly easy to find or even terribly common attack, but it is devastating if it works. Additionally, there is a chance I can do remote file inclusion. I can reach out to a file on my server that will then cause your XML parser to do something it doesn't want to do. So, what does this all come down to? Two things. One, having an XML parser that is broken is devastating to your applications. The Java is particularly famous for this. They very commonly, going back just 2 or 3 versions ago, had XML parsers that were terribly broken and that were vulnerable to this, and many people are still using older versions of Java. So that's where you run into this in applications today, is primarily in Java applications. But it's not, I don't want to just poke fun at Java. Rails had this problem with several of their XML parser gems, and PHP has an XML parser that's broken, that's still in common use. So if you have a broken XML parser, the possibility that I can do one of those two inclusions is very high, even if I have to do man in the middle and intercept it halfway through. The second piece is that developers should, once again, do input validation on all parts of the XML document. If you are expecting the entity tag, you have to make absolute certain that value that comes in that tag is one of a list of known good values for whatever external entity you're expecting to be brought in, a DTD file or whatever it is. That is on the developers. That's not something necessarily the XML parser can solve for you. So the developers need to make that work. Why did this show up all of a sudden? There was a particularly egregious set of flaws in the Java XML parser that made a lot of news. And because of that, static scanners started looking for it. So they would look to see, so like Veracode, for instance, would start to look and see, hey, you're accepting an XML document, but you are not validating the entity tag. Therefore, you probably are vulnerable to XML external entity injection. Now, is that always true? No, because it might be being checked elsewhere, or your XML parser might handle it, or. But it showed up on all the lists because of that. Also, it's like injection. When it does happen, it's particularly egregious. If you're in a .NET environment and I can, upload an XML file that then shows me your web.config file, there are a lot of secrets in there. There are private keys in there. There are passwords possibly in there for your database. A lot of secrets that are very important. So it is an extraordinarily egregious finding if it can be exploited. So that's why I got bumped all the way up to A4. And I'll show you some code here in a couple minutes, just so you get an idea what it looks like. It's funny because I went all the way back to .NET 2, and I couldn't actually make it work, my demo work. That's how good .NET's XML parser is. This is a replacement machine. I don't have Eclipse installed on it, so I can't show you Java code as easily. But you can do it in Java, but you can't do it in .NET. But I'll show you the .NET code so you can see. So insecure deserialization. This became all the rage because of the attack that brought down Equifax. That was also insecure, known insecure component. And for some reason, it's one of the Apache products. Struts. Thank you, Struts. That's exactly right. Struts featured, and still does, some people say, an insecure deserialization. So what this means, and I'll show you an example of this in a couple minutes, so I'm not going to go into a lot of depth, but if I take an object in my system, okay, a class that I've instantiated into an object and filled with data, I can serialize it, turn it into a string of ASCII that I can then save somewhere, say in a cookie or in a hidden field in a web form or in a file. For instance, games do this all the time. They save your state in a base64 encoded serialized object. If you know how to deserialize it, you can cheat on the game. That's how people do a lot of the stuff they do. And like you see YouTube videos do crazy things in games. That's how they do it. They deserialize the state of the game and then modify it and then reserialize it, rebase64 encode it, and then run the game. The game picks up that it doesn't know it's been changed. That is insecure deserialization. Particularly difficult to fix for the developer, especially if you have, like for instance, game level, if your character is level 7 in the game and you figure out how to deserialize the game state, make yourself level 77, that game can't, that file is the truth. There's no input validation that'll fix that. So, the only thing you have left to do is further protect your serialized file with encryption or something of that nature. Though even that's difficult because the private key is hidden somewhere on your machine. It's got to be. So there's a lot to that. But in the web world, we very commonly save serialized state in a hidden field, often called a view state. MyFaces does it. NAS.NET Web Forms does it. And Rails, one of the Rails platforms does it. And several PHP, like Laravel, does it as well. Those are serialized objects. If you can deserialize and edit them, and then rerun the request, you can do damage. You can do injection. You can change the way the application works. Particularly powerful attack. Very difficult to find, but particularly powerful attack. And this is my favorite new finding. This is A10 now. And you'll notice it's not a vulnerability, right? There's no way to exploit insufficient logging. But this is a very, very important message to developers. Because it's not just about logging errors. This is about communicating security information using your log files. The example I always give is, if you have a drop-down for state, and by state I mean like state of the United States, right? You're filling out an address form. If you get a request that has something other than one of the 50 states in it, your application is under attack. Because you know for a fact that whoever sent that request did not use your web form. They used an attack proxy or a script and directly spoke HTTP to your server. So that is a security event. Developers do not know this, and they must. And that is what insufficient logging is all about, is that finding. So let's look at a demo. Oops. How much time do I have? Oh, I got lots of time. I said demo and everybody's getting up. Don't get up. This is fun. So you have to wait for Visual Studio to boot. Sorry about that. You can, yeah, absolutely. Ask questions. Sure. Say that one more time. Oh. Why is reflected XSS not included in injection? For some reason, OWASP separate, well, I told you it's sort of the reason, cross-site scripting and injection. Because to them, injection is server-side, and cross-site scripting, browser injection, is client-side. So server-side attacks affect everybody on the system. Client-side attacks, one person at a time. So they keep them separate. XSS includes stored, reflected, and DOM. All in there. They're all in the document. Stored is in there as well. Yeah, all three of them are in the document. But they're not. But they're in cross-site scripting. They're not in the injection side. Injection side is for server-side injection. Okay, so let's try to remember how to use Visual Studio. Step one. Okay, so let's look real quick at the serialization piece here. This is the right one. Startup project. Okay, so we have this simple console application here. So it accepts an argument, which I'm just going to use the debug console to do. And what it does is it has a save and a load, right? And what it's going to do is it's going to spin up this serializable class, which you see is just a simple class with two properties, a string property and an integer property. Just to give you an example is all we're trying to do here. And you know, I really should have set this up. I don't know what I was thinking. I got to talking to everybody and didn't do my normal setup work. So just so you know, I'm not cheating. No, that's not right. So here's my command line arguments, right? So I'm going to do a save here. Save that down. So what this is going to do when I run it is it's going to spin up the serializable class, and it's just going to populate it with hello world and 42, right? And then it's going to use the binary formatter object in .NET. The binary formatter object is known vulnerable. Okay? It doesn't do any external protection of a serialized class at all. And you will see that in just a second. So it's just gonna stream it out to a file and save it in my temp folder. And NuGet's gonna throw an error, but it doesn't matter for this. Okay, so we go over here, and here is our output, and we can look at that. And this is why this is hard to find. Obviously, if you spin this up, this doesn't look like something you can do anything with, but anybody who spent any time in development know this is just an encoding problem, right? So if I reopen as UTF-8, I'm sorry, the font isn't very big. Like I said, I had to replace my machine, and I haven't done everything I normally do to make things bigger. But you can see in here, here's to make the easiest one, here's our hello world text right here that we've set. Okay? So if nothing else, our text is editable. So for instance, if your developers are using a view state and they're saving say the logged in user's role in some kind of super cookie. Okay? This is an example of insecure deserialization. If I can deserialize that object, even just using a text editor, and do, and then change the text, right? Well, before I do that, hang on. Let's prove, well, no, it's okay. We're running out of time, so I'll just do this side. It's got to be the same length, right? Because I'm not going to edit anything else about the object right now. And I save this up, and I go back and I change this to the load feature. What happened to my, there it is. So now I'm going to load it back up. So this is your web server accepting the cookie being sent back by the browser and then rehydrating it, right? And I go back here, you'll see that my load conditional right here, all it does is spin up the serializable class and populate it with whatever it picked up from that file, and then it's going to write it out to the console for us. And as you can see, it's a little small, but it says hello BSides instead of hello world now. So that is exactly how this injection could happen. Now, if I knew, for instance, that there was something being processed by the back-end server, I may be able to do injection here, but certainly I can at least change the data, well, modify the way the program works in such a way that the developer, they assume that everything's going to be fine. Very rarely the developer is going to do input validation on something that's this heavily obfuscated. But the fact is the attackers know how to do this now. And that's why it was added to the OWASP top 10, is because this has become a much more common attack these days. The attackers on web applications have become much more sophisticated. We've ramped up our security. They've ramped up their knowledge and attack level. So this is something that happens today. Any questions on that example? I'm just about out of time, so I'm just going to show you real quick my sample code that doesn't work for XML. You can see here, this is the simple XML document I was trying to send in that was going to load up this text data.txt and then populate it when it showed it on the screen because it's in that entity tag. But no matter what I do, I cannot make .NET do it. I can do it in Java, but I can't make .NET run it because the XML parser is so well written. The Java XML parser just was not as good. So, but this is an example of what I was talking about, the entity tag. That's it. That's what it looks like. And you think to yourself, XML? Nobody uses that anymore. Not true. XML crosses the boundary of your applications all the time. It's still heavily used. One of the main examples, though configured properly, it's very difficult to do injection on, is if you're doing any kind of single sign-on with SAML. That's all just XML, and it's part of your authentication system, too. So it's a pretty big deal. So that gives you a little bit of an idea of what this looks like on the code side of things. If anybody ever has any questions, I'm super easy to find. Oh, yeah, let me walk through a couple. Oops. So, real quick, take-homes for your developers, right? Security requirements. OWASP ASVS. ASVS, application, I don't remember what it stands for. Vendor, no, I don't. It's ASVS. Look it up. Best list of security requirements out there. Moving to security architecture, same document. Standard controls, right? Standard security controls for your developers. Work with your system architects so that people aren't always downloading the latest whatever. Standard set of secure controls for user interfaces. Implement a secure development lifecycle. I heavily recommend the Microsoft SDL. It's free and it works. It's what they put in place between Vista and, no, between XP and Vista? No, between Vista and somewhere in there, whenever they stopped everything and actually made Microsoft secure, that's how they did it. Read it. Worthwhile. And then finally, get them some training. It's definitely worth it. Lots of good training providers in Cleveland. Can't find anybody, call me, I'll come up. I'm happy to do that. But that's it. I'm easy to find online. If you have any questions, the @ sign is for Twitter. I'm a big fan of Twitter. It's a global conversation. I like that. I do hang out on IRC. You can find me on #security. I'm all over Google. So if you just Google my name, you'll find me. I wrote some books. So once you've done that, your online privacy is shot. So I'm super easy to find if you have any other questions. Other than that, thank you very much for listening and good questions, and I'll see you all around. Thank you. So is it off now? Yes, it is.